In this video, I'll talk about the flash memory, um, the structure, and how it operates. So flash memory is one of the non-volatile structure of the memories. Um, the structure of the flash memory is really similar to the current MOSFET. However, there is a floating gate, which is a conductive layer that is placed between the control gate and channel. Uh, and floating gate makes the device to trap or and hold the electrons even when the power is off. And there are three operations of the flash memories: write, erase, and read. So for the write operation, when we apply the positive bias to the device, uh, the electrons gets enough energy to go through the oxide layer, and the electrons are trapped in the floating gate. Uh, and it makes the threshold voltage of the device higher. Uh, yes, and for the erase operation, it is opposite to the right. Uh, when the negative bias is applied to the device, the electrons trapped in the floating gate are pulled out uh, by the FN tunneling and lowering the threshold voltage of the device. And for the last, we have read operation. Read checks whether the device is on or not, which means device is conducting or not. When the floating gate has electrons trapped inside, the threshold voltage is very high and there is no current flowing in the device, which means the device stays off, indicating the zero. And in opposite, when the floating gate is empty, I mean, when there is no electrons in the floating gate, the threshold voltage should be low and current is flowing, which means the device is uh, in state of one. And there is two key points of the over flash memory, over the performance of the flash memory. One is retention and the other is endurance. Retention means how long the data can be stored to the floating gates, and endurance means how many times we can write and erase the data before the device dies. So that's about it for this video.